Hello and welcome to Badger Talks Lives, which brings exciting happenings, resources, and talent from your UW flagship campus to the people of Wisconsin and beyond. I am Austin Dillman from Greendale, Wisconsin. I'm a rising sophomore studying microbiology in the UW Madison College of Agriculture and Life Sciences. Today it is my pleasure to introduce Professor and Extension Wildlife Specialist David Drake. Today, David will be sharing insights on the UW Urban Canid Project, which serves to better understand how red foxes and coyotes coexist with each other and humans in urban areas around Wisconsin. With degrees from North Carolina State University, Texas A&M, and Macalester College in Minnesota, David's research and extension programs primarily focus on wildlife and wildlife damage management in human-dominated landscape. Please welcome David Drake.
Thank you very much, Austin, for the introduction, and thank you very much for inviting me to do a Badger Talk. So I'd like to share with you a project we've had going on since about 2014 here in Madison, where we are live trapping and radio collaring red foxes and coyotes to have a better understanding about how they're navigating the urban landscape and generally urban ecology of these fascinating canids. So the coyote that you see there in the left-hand picture and the red fox you see on the right-hand picture are extremely adaptable animals. They're what we consider habitat generalists, so they can range across a wide variety of different types of land uses and land covers. Even though we think of them as carnivores, as meat eaters primarily, they really are omnivores and are diet generalists and can eat a wide range of food, both natural and human-provided food. Because of this adaptability, there probably is not a city in North America that is not occupied or colonized by both coyotes and red foxes. And they do quite well in these urbanized environments. The coyote that you see over here on the left-hand side, there's quite a bit of information already known about urban coyotes. The longest running urban coyote project in the world was based out of Chicago. It has been going on since the year 2000. So there's quite a bit of information known about urban coyotes, both from that project. There's projects going on in Los Angeles, Phoenix, Arizona, New York City, Atlanta, Georgia, and other places like that. The red fox, however, there's not much known about these animals that in cities in North America. And like I said, they are certainly occupying most cities, if not all cities in North America, but we know very little about them. If you look at areas in Europe, for example, in London, red foxes have been documented in urban areas since the early 1930s. And there's more known about red foxes in urban areas in Europe, but we don't know how well that transfers or translates to red foxes in North America. So that was one of the reasons we started throwing red foxes into the mix, to start studying the urban ecology of red foxes, simply because not much is known about them here in North America. And there's very little known about these two species and the relationship in an urban area. So if you look at the literature for coyotes and red foxes in non-urban areas, so in wildlands or rural areas, typically coyotes are about 3 times the size of a red fox. And in areas where you have coyotes, you typically do not have many, if any, red foxes, because they overlay or overlap in the types of areas that they use. And because coyotes are the bigger animal, that they are able to exclude red foxes from those areas or their territories that they're occupying. And if red foxes don't observe that exclusion, if coyotes typically, if they will catch a red fox, they will usually kill that animal to limit competition for resources like food and areas and things of the land and things like that. So there's not a lot known about these animals or the relationship between coyotes and red fox in urban areas. And that was another reason that we wanted to start studying these two species and started doing so since 2014. So we've had this project going on for a little bit of time, and what I'd like to do is give you a bit of a high-level summary of some of the aspects of this project that we've either completed or we have ongoing research. I'll talk more about that near the end. But I'd like to share some results of 3 different objectives we've had, or 3 different studies we've had ongoing and have completed. And the first being examining the spatial ecology of how these two species navigate this urban landscape, and more specifically, how do these animals coexist, or do they coexist in these urban areas, or that relationship where there's this competitive exclusion that we see in non-urban areas, is that type of a relationship holding up in urban areas? So that's one of the objectives that we started looking at, and that was one of the very early objectives we started with this research project. The other thing I'll cover a little bit is some of the disease issues of these animals. And we had a project going on where we started looking at how healthy these animals are from a disease aspect. And the last thing I'd like to cover today is specific to coyotes, and that is using a citizen science portal that we have, where people are able to report these encounters that they have with coyotes here in Madison. And we wanted to have a better understanding about what these human coyote encounters look like, and I'll talk a little bit more about that. But again, in the interest of time, and because we're trying to provide a synthesis of some of our research since 2014, it's kind of going to be a high-level summary. So if you have questions, certainly include those, and I'll try to get to them as quickly as I can at the end of the talk. Or if you have questions about more details or want more details about some of our methods or some of the results, certainly ask those, and I'll try to provide them as time allows. So this is our study area here, and essentially it's the western half of Madison. So if you're familiar with Madison, Wisconsin, that dark area on the top middle of the slide, that's Lake Mendota, and the southern shore of Lake Mendota kind of borders the northern part of our study area. Off in the kind of the southeastern corner there, that's Lake Monona, and that borders the eastern edge of our study area. And then the Belt Line, which is a highway system that kind of encapsulates or encloses Madison on the east, west, and south sides of Madison. The southern part of the Belt Line and the western part of the Belt Line kind of borders our study area as well. And then we have a few surrounding communities on the south and west side of Madison, some of the suburbs there that are also in our study area. And as you can see here, we've used what's called a national land cover database to look at the land use, land cover. So obviously the bright blue there is water, the darker green is natural area. And then we've got what we would call developed open, which are things like golf courses, soccer fields, cemeteries, things of that nature. And then we have different levels of development. So one level of development is 80% and higher of either built area or impervious surface. So 80% of that area is either sidewalk, roadway, or some kind of a building. And then the other type of development that we looked at was moderate development, from about 25% of built and impervious surface all the way up to 79% of built impervious surface. So that's what all those different colors mean. And I'll talk more about the relevance of that in just a few minutes when we get to the results of some of our research. So just to give you some general ideas and quick summary of the methods that we use, starting in the upper left-hand picture here, we use a type of live trap called a cable restraint to catch these animals. And so essentially we trap for coyotes and red fox in the city of Madison in our study area, generally from between November and March, somewhere in that period of time. Usually we trap in the winter because if there's snow down, it helps us see where these animals are tracking, and it helps us figure out where to set our traps. There aren't as many people out in the winter as there are in the summer, so we don't have as many people and dogs and dog walkers possibly interacting with our traps. And these animals are a little bit more active in the wintertime simply because it's colder, and also we're overlapping with their breeding season, and they get to be pretty active in the breeding season. So we have a much more, we think, an easier opportunity to catch these animals. And like I said, we only live trap these animals, so we use a cable restraint. As you can see, that's a wire loop that we set specific to either coyotes or specific to red foxes. We catch them around the neck, and it holds those animals in place. And when we have traps set during our trapping season, we check the traps every single day, first thing in the morning. And most of the animals we catch at night, so at the very most, they might be sitting in that trap for 12 hours or so at the very most time. Every animal we catch, we check them, make sure we haven't harmed them with their trapping. And we've caught probably close to 50, 55 animals, and every animal we've checked, we've had no negative consequences of using these live traps. We follow best management trapping practices and things of that nature. So once we catch an animal in the trap, we will restrain it around the neck with a pull noose, and then we'll give it a sedative. And then once we sedate the animal with a hand injection in the back leg, we back away from that animal for about 10 minutes to let the sedative act, work on the animal. And once the animal is properly sedated, we'll put a muzzle over the mouth to make sure that we can handle the animal if it does wake up from our sedation before we're ready to release it, so we can resedate it without getting bit by the animal. We weigh the animal. We look at the overall body condition of the animal. So we look at the eyes, we look at the teeth for general aging. We weigh the animal. And once we've done all of that, we draw blood. We try to get 6 cc's out of every animal, out of one of the front leg veins. We swab the nasal passage with the Q-tip, and then we'll take a second Q-tip and we'll swab the rectal passage. And the blood and the nasal and rectal swabs are for our disease work to see both what these animals have been exposed to and what diseases they're currently carrying. And so we'll do all of that. And once we've completed our sample collection, we'll we'll tailor fit a collar to each animal. This collar that you see in the upper left-hand picture is a VHF collar, a very high frequency collar, which requires students, such as you see in the lower right-hand picture, to go out with an antenna and a receiver and actually physically find that animal using that antenna receiver contraption. And typically with VHF animals, we would find those animals once a week, and we would locate that animal over a 5-hour period. So over a 5-hour period of time, each week we get one location per hour. So we would have 5 location fixes per animal per week. And that was the first couple of years of our research. Since then, we use a different type of a collar. We use a satellite collar. And those collars do not require any student or any person to go out and physically find the animal. The satellite collars bounce the signal off satellites in the sky and then right into our computer. So we get much more refined location data on each animal using the satellite collar than we do VHF, but the satellite collars are probably about 6 to 7 times more expensive. So it's definitely a trade-off between the amount of refined data, movement data we're looking for relative to the amount of cost that we actually want to pay for the collars. Okay, so after we collect all the data and we've got the animal collared, as you see in the upper left-hand corner, we've taken all of our samples. Then we give the animal a different drug to reverse the sedative we gave. We stay with the animal until the animal is fully awake and has left the trap site under its own power. And then we'll start tracking that animal over the life of the animal or the life of the collar. And typically the batteries in these collars, be it VHF collars or satellite collars, typically they last, we try to get about 2 years of data out of each collar. So sometimes the animals outlast the collar and sometimes the collars outlast the animals. It all depends on what's going on with each animal. Okay, so here is, I'd like to move away from our methods and into some of our results. And I'm going to start talking about our first objective we wanted to look at, and that's understanding the urban ecology of these animals. And so kind of how are they navigating that urban landscape? And more specifically, do these animals coexist with each other in this urban landscape? Again, to remind you, if you look at the literature for non-urban coyotes and red foxes, these animals overlap where they live in the non-urban habitat, but they don't coexist simply because the coyotes will not allow the fox to live in those same areas so that they don't have to compete for limited resources. So to explain this a little bit, this is more or less our study area from a satellite map view. Every polygon that you see there, so each one of those mint or green polygons is one coyote that we've tracked over a 2-year period, and each one of those red polygons is one single red fox that we've tracked over that 2-year period. So if you look at the right-hand side of this map here, we would say that generally these animals are spatially separating themselves. And again, because the coyotes are about 3 times the size of a fox, the fox is the vulnerable one in this relationship. So if anybody's going to get killed, it's going to be the fox that's going to get killed by the coyote, the get killed by the fox. So if you look at the right-hand side of this graph, a couple of things to recognize is it does look like there's spatial separation. There is some overlap between the red and green polygons, but for the most part, the fox seem to be staying in their own area and the coyotes are staying in their own area. And a couple other things to notice about this picture here is for all the green polygons, they are typically centered around urban green space. And so this is very consistent with what we found in our findings relative to other urban coyote research, that coyotes that live in cities, they tend to congregate and concentrate most of their time in urban green spaces. So parks that have natural vegetation and things like that. And that lower picture that you see down there, that's the UW Arboretum. So that's a 1,200 acre contiguous natural area. And as you can see, the coyotes don't typically leave the UW Arboretum. The next polygon, the green polygon you see directly above that, that is Picnic Point in the Lakeshore Nature Preserve, if you're familiar with the UW Madison campus. So that's a sizable area of natural area, and that's another reason you see those coyotes kind of congregating around that natural area. If you move to the polygons to the left, those polygons are larger and they will stretch out away from those natural areas. They are centered around Owen Park, so OWEN Park, which is about a 110-acre park. And it's a Madison park, part of the Madison Park system, but it's a natural park that has natural vegetation in that 110-acre area. However, the 110 acres is not a large enough area to contain those coyotes so that they can find everything they need to live there. So that forces them to go outside that Owen Park area. And that's why you see those polygons that are larger typically than the other polygons you see on the right. And it also that you see those coyotes actually expanding outside these natural areas into the more of the built landscape. If you look at the red polygons, those foxes tend to isolate themselves or tend to use more of the built landscape, and they don't concentrate so much in these natural areas like the coyotes do. And so if you look at the right-hand side of the picture there, we see some spatial separation where the coyotes are using those natural areas. The fox are kind of staying away from the areas where the coyotes are. And so if you were to ask us, is that relationship between the coyotes and fox holding up in the urban areas like it does in the non-urban areas, we would probably say, looking at the right-hand side of our picture, it probably is holding up that way. If you look at the left-hand side of the picture, however, where you see those coyotes in Owen Park, that there's a lot of overlap between the coyotes and the red fox there. And so that kind of muddles this picture where spatially these animals may or they may not be separating themselves to avoid each other. We don't, each species, we don't know that yet from this picture. So one way these animals could separate themselves is spatially. They could occupy different parts of the landscape, and so the fox could avoid the coyotes that way. Another way that fox could avoid coyotes is to be active at times of the 24-hour clock when coyotes are not active. And so we looked also at activity patterns, and that's what you see here. The blue bar are all the coyotes summarized as one bar. The green bars are all the fox summarized as one bar. If you look at this picture, and this is the temporal scale, so looking at time of activity, that the fox don't seem to be separating themselves based on time of activity. So the coyotes and the fox are active in the same parts of the 24-hour clock, and primarily it's around sunrise, sunset, and mostly at nighttime. So these animals are primarily nocturnal in this urban landscape, and that's another thing that allows them to be able to live in these cities, is because they're so adaptable and they're very flexible in their activity patterns. They can be nocturnal or they can be diurnal depending on what's going on in that landscape. But for our animals, and again, this is pretty consistent with urban coyotes, at least in North America, that urban coyotes are typically a nocturnal species, and it looks like urban red fox are a nocturnal species as well. So if the fox are trying to avoid the coyotes, they certainly are not doing it from a temporal scale like they were from a spatial scale in the previous picture. So at this particular point in our research, when we were just starting out, we weren't sure what to tell people, if that relationship between coexistence or non-coexistence, what that was like, because we were getting a muddled picture where we were having some spatial separation, we were also having some spatial overlap, and now we're getting some temporal overlap. So we weren't quite sure exactly what that relationship in the urban landscape looked like relative to the non-urban landscape until this set of pictures came up. And this kind of cemented for us how these animals live in the urban landscape. And so just to set the story here, this is a fox den under somebody's garage, a two-car garage in Madison. This is about maybe a half mile south of the University of Wisconsin campus. And so there was an active fox den under this garage, and we're looking at the back side of the garage. There was a entrance to the fox den on the back side of the garage, and there was an entrance to the fox den on the side of the garage that you can't see. And we had wildlife cameras up on both entrances just to monitor the activity of the fox. And so we would check the SD card of these cameras periodically. And one day we get the SD card out, and we were very, very surprised to see what we saw. And so I'll explain what you're seeing here. So essentially, all this bush is forsythia. There's a big mound of soil kind of in the middle bottom left-hand part of this picture, and that's all the soil that these foxes have excavated underneath the garage so that they could have a fox den there. And then you see the animal up alongside alongside the garage, excuse me. That's one of our coyotes. And if you look closely enough, there's a coyote there. That coyote is collared. And that coyote is collared. We caught that animal at the Lakeshore Nature Preserve. So that animal has moved about a mile away from where we caught it and is over now investigating this fox den. And what you can't see yet, but you'll see in a minute, if you look closely on this mound, you'll see the form or shape of an animal coming up from the bottom of this mound. And that's the male fox that owns this den. So right now, we've got the coyote and the fox about 10 feet apart from each other. So the next picture we see in the series here is the coyote is now sniffing the entrance to the den, and the male fox is now sniffing the coyote. And as you can see on the male fox, you can see the antenna down the middle of that animal's back. That's male fox is also, we captured and collared this male fox prior to it denning. So this all of a sudden now, if that coyote wanted to turn around and catch that fox and kill it, it could do so very easily. So this was the next series of pictures we saw. And the final series of pictures we saw are these two knuckleheads standing apart like this for about 10 minutes, just staring at each other. And that's all they were doing, is staring at each other. So again, if this fox felt vulnerable, there's no way it would have been sniffing the coyote, and there's no way it would have stood there for about 10 minutes just staring at the coyote. As this was going on, we had also over about a 3.5-week period that we had all the cameras on this fox den. We also, for about 2 weeks, had a film crew with us that we stationed at this house. And so we got video and still photography. And over that 3.5 weeks that we had some kind of either photographic or video documentation, we noticed that about every other day, either this coyote and another coyote from Lakeshore Nature Preserve would come over to the fox den every other day. And what turned out they were doing is the male fox here and the vixen, or the helper fox, excuse me, not the vixen, but the helper fox, they were bringing whole rabbits and whole squirrels back and leaving them at the den entrance for the vixen and the kits to eat. And there were 3 fox kits that were part of this den at this time. And so the coyotes were coming over for a free meal. They were coming over to eat the prey that the fox were bringing back for the kits. And so they would eat, and then they would go away. And then a couple nights later, they would come back for a meal, and they'd eat, and then they'd go away. And at no time did these coyotes ever make an aggressive move to the kits or the adult fox. And at no time did the fox feel vulnerable enough to move the kits out of this den to another den. They had at least 4 other den sites that they could have moved to within their territory. So now we had photographic and video evidence that these animals actually are able to coexist in the same space in the same time, and they can do so peacefully, where there's not an aggressive move from the coyotes toward the fox to exclude them. And what we think is driving this or allowing this to occur is in the urban area, there's just such an abundance of food that these animals can share that abundant resource. They don't have to compete for a limited resource. And I'll talk a little bit more about that when I start concluding the presentation and talking about ongoing research. Okay, so then the next thing I want to talk quickly about are some of the disease issues. And as I mentioned, we would draw blood and nasal and rectal swab every single animal that we caught. And we did this in order to get a sense about how healthy these animals are from a disease standpoint. And so we looked at a couple different points in time in each animal's disease history. So the blood we would spin down, and we look at the antibodies to see what antibodies these animals were carrying. That would give us an indication as to what diseases these animals have been exposed to at some point in their past. And then for the swabs, we would do a PCR genetic test on those swabs, and that would tell us what diseases these animals are currently carrying. And so we looked at things like leptospirosis, distemper, adenovirus, parvovirus, anaplasma, and ehrlichiosis. And those, none of those diseases really showed a definitive trend or sign in the data. And there really wasn't much difference between both coyotes and fox with those two diseases, or with all those diseases. So they weren't of great interest to us. The 2 diseases that really popped out and were statistically significant or were statistically different between coyotes and fox were both heartworm and Lyme disease. And heartworm, of course, is a mosquito-borne disease. And once the mosquito bites a canid or a domestic dog or a wild dog like coyotes or fox, it can infect that animal with heartworm. Lyme disease is obviously a tick-borne disease. And so what we found with our coyotes is about 1/3 of our coyotes had Lyme disease. None of our fox had Lyme, or excuse me, about 1/3 of our coyotes had heartworm. None of our fox had heartworm. And about 2/3 of our coyotes had Lyme disease. And only one of our fox, or 7% of the fox we tested, had Lyme disease. And so there's clearly a distinct pattern here. And what we think is going on is how these animals are actually spatially separating themselves on the landscape. There is some information or some suggestion in the literature that foxes may not be susceptible or as susceptible to Lyme disease and heartworm as coyotes are, but we don't think that that's what's going on in our system here. What we think is happening, and the reason that coyotes are so susceptible to Lyme disease and heartworm is because they will spend so much more time and concentrate themselves in these urban green spaces. So if this picture in the lower right-hand picture, if you look closely enough, there's a coyote that's in there amongst that dead grass. And that's where coyotes hang out, is in these urban green spaces. And because they're in these urban green spaces, that there's just so much more abundant and preferred tick habitat, and there's a lot of standing water in the landscape, so there's much more abundant mosquito habitat. And we think that the coyotes are just much more susceptible or exposed to ticks and mosquitoes, and therefore are much more susceptible to both Lyme disease and heartworm. As opposed to the red fox that you see here in the left-hand picture, again, as I mentioned in the earlier satellite map, the coyotes tend to concentrate in these urban green spaces. Foxes tend to concentrate in the built environment, or they really associate themselves with areas that humans are also living in. And we think that at least from a disease standpoint, that's keeping red fox healthier than it is keeping coyotes, because as the red fox are living in these urban areas that humans also occupy, humans typically don't like mosquitoes and we don't like ticks, so we usually treat the area for both of those vectors. And then also in urbanized areas or more human-dominated landscapes where humans are living and residing and working and playing and things like that, that we just don't have very good tick habitat. So we keep the vegetation pretty well mowed. A lot of that water that's on the landscape runs off the landscape into urban storm sewers, so we don't have a lot of standing water. And because of that, we don't have a lot of ticks and a lot of mosquitoes in that urban landscape where these fox are. So we think that fox just are simply not as exposed to ticks and mosquitoes as our coyotes, and that explains why we see that difference between heartworm and Lyme that is species specific. All right, the last thing I'd like to just kind of briefly touch on here is the third objective, and we're going to focus just on coyotes here. But we're looking at human-coyote encounters, and there's a lot of concern in urban areas with animals like coyotes, because coyotes are known to attack pets, especially smaller dog species. If you go to California, and Southern California in particular, that there are regular coyote attacks on humans where coyotes will actually chase after or bite humans, and that occurs about maybe once a month or something. Thankfully, we don't have that in Madison, Wisconsin. We have had coyote attacks on dogs in years past, but we haven't had coyote attacks on dogs probably since about 2011 or 2012 here in Madison that we're aware of. But nonetheless, we wanted to look at this because most of the human coyote encounters that are reported in literature are very negative. So it's always reporting some negative encounter where a coyote has attacked a dog, or it's attacked a human being, or something of that nature. And most of the encounters that are reported in the literature are based on either anecdotal evidence, media accounts or reports, or surveys where humans have been surveyed about their experience with the coyotes. But one of the things that we have going on with our project here is we have a citizen science portal called iNaturalist, and essentially we've created an iNaturalist page specific to our project, where anytime somebody sees a coyote or a fox in the Madison area, we would ask them to go to our iNaturalist page and report that sighting. And so what we've decided to do is we took all of the human coyote encounters that have been reported to our iNaturalist page, and we wanted to look at those to see what does that human coyote encounter look like. And for each encounter that's been reported, the person who reports that encounter will tell us the time of day or night it occurred, the date, the geographic location it occurred. And then we ask each person 8 optional questions, such as estimate the distance between you and the coyote. Did you have a dog with you on a scale of between 0 and 5, 5 being aggressive, 0 being not aggressive? Estimate the coyote's aggression and things of that nature. And so we wanted to kind of summarize all this and really try to look at what does that human coyote encounter look like in Madison. And the other thing that's unique to this is that we have the ability to take first-person accounts as they occur, instead of third-person accounts such as anecdotal accounts, media reports, or survey information. So I'm going to just give you, again, kind of a high-level summary of some of the results that we found here. But one thing, and you can see the variable is some of the questions that we've asked and some of the variables that we've collected data on to start examining these human-coyote encounters. But one thing I want to report is this estimated aggression. And so we report here about 398 human coyote encounters. So we don't have 398 coyotes in the city of Madison. So a lot of these encounters are different people who are reporting encounters with the same animal, but it's different people with the same coyote. But of the 398 people that we've reported here, 90% of the observations have estimated that coyote aggression was calm, or a 0, which is as calm as we can get. If we look at the other 10% of the observations, about 7 of those 10% estimated the coyote aggression is at 1. So essentially 97% of these human coyote encounters are reported as the coyote is extremely calm, as not making any aggressive approaches toward people at all. And again, as I mentioned, we asked people to report between 0 and 5. So 0 is completely calm, 5 is very aggressive. The highest that anybody ever reported was 2. So generally, these animals in the Madison are very, very calm, and they're not aggressive toward people or toward dogs at all. The other thing I'll just quickly show you here, one of the things that we push out a lot of information to the public here in Madison. So we really consider this project both a research and an outreach or extension project, because we do so much public outreach in this project as well. And one of the things we really emphasize to people is if you see a coyote specifically, but animals generally, we really want you to enjoy watching that animal from a safe distance. And after you've had a time watching that animal, especially for coyotes, we want you to harass that animal so that we can maintain or instill the fear of humans in that animal. And that's the best way that we can promote positive coexistence between coyotes and humans, is that when a coyote sees a human either walking or in a car, they move away from that person. And as long as the coyote's moving away from people, then we're going to have generally positive coexistence between humans and coyotes. And so 55% of the time, when we ask somebody, when you saw that coyote, or the coyote, when it saw you, did the coyote move away from you? And 55% of the time, people indicated that yes, the coyote did move away from them. We'd like to see that number a little bit higher, but at least a majority of the time, coyotes are moving away from human beings, and that's a good thing. So most of what we find here with the human coyote encounters in Wisconsin, most of those encounters, almost all of them, are benign, and the coyotes are very calm and are following humans because they're either curious about what the human's doing, or maybe the human's walking a dog and that coyote's curious as to why another canid is in its territory and things like that. But generally, there's no aggression going on toward humans or toward domestic pets, which is a very, very good thing here in the city. Most of the human coyote encounters that we encapsulated or summarized occurred during daylight hours. And so that's interesting, because if you remember that graph where I showed you that most of the activity pattern of coyotes is during the nighttime, coyotes are moving most of the time during nighttime, and that's when they're primarily active. But during the nighttime, if somebody's out walking their dog, it's not as easy to see that coyote during the night as it is during the daylight hours. So that's why most coyotes are being reported during the daylight hours, and most of it is around sun up, sundown. So it's not in the middle of the day as much as it is when the coyotes are waking up to start being active at night, or they're coming back from their nighttime activity and they're starting to go to sleep. And that's when people are seeing coyotes. Most of the time is around sun up, sundown. Most of the encounters that were reported were relatively close to roads. So on average, we're about 50 yards away from a road, which makes sense because that road provides great sight lines for the human being. So you can see a lot of a distance down that road, or if you're driving your vehicle, you could catch that coyote in the headlights of your vehicle. The other thing about roads is you don't have a lot of vegetation right up to the road. So there's a lot of very good sight lines, and it's easier to see the coyotes along a road than it would be, for example, in an urban green space. And most of the human coyote encounters occurred during coyote breeding season. So that was typically here in Madison, at least, is typically between December and March. And there's a couple of reasons why that would make sense. Number one, during the coyote breeding season, that's when coyotes are most active, and they're wandering around the greatest amount of distance or greatest area, because they're not only patrolling their territory, but they're also out breeding with the females, getting more food and things of that nature. But also December to March, we don't have vegetation on our trees up here in the northern climate, and so you can see a lot further distance through that vegetation in the wintertime than you can in the summertime. So that all the reasons why people are seeing coyotes during daylight hours, close to roads, and during coyote breeding season make perfect sense. And like I said, most of the iNatural users were reporting the same coyote, but that same coyote was being reported by multiple people. All right, so just to summarize or finish up quickly to let you know about some of the ongoing research we have going on. So I've got a PhD student that I'm co-advising with a colleague of mine, and she is starting to look at what is allowing this coexistence between coyotes and fox here in the city of Madison. And what we think is allowing that coexistence is simply because there's such an abundance of food on the urban landscape that these animals can share that abundant resource. They don't have to compete for limiting resource. So Morgan, the PhD student, she's starting to look at that. And we're looking at coyotes and fox and how they coexist in Madison. And then we're looking at coyotes and fox and how they coexist or don't coexist in Iowa County, which is our rural study area. And in addition to that, we're going to go out and trap the amount of prey that's in each of these study areas, urban versus rural. So we'll have a sense about the abundance of prey, and we'll also have a sense about the diversity of prey. And then we're going to collect scat, or polite term for poop. We're going to collect coyote and red fox scat in urban versus rural areas. So we're going to have the ability to look at what's available to these animals to eat relative to what are they actually eating. And again, our assumption at least is that we should see a much higher and more abundant food base in the urban area. And perhaps that these animals in the urban area are eating both natural foods and human provided foods, such as garden items, trash, things of that nature. Whereas in the rural area, we should not see as much abundant food, and we should see primarily a natural diet, not so much human provided food source. Some other things that we're looking at is with our satellite collars here, we have the ability to look at both red fox and coyote at the same time in that 24-hour clock. And so we're really curious about what do these coyote fox encounters look like when these animals meet like they did at that fox den. So for example, who's initiating that encounter? Is it the coyote is moving toward the fox, or is the fox actually moving toward the coyote? And are those encounters occurring inside a fox or coyote territory, or are they occurring outside of these territories? And are these encounters consistent throughout the year? Or while these animals are breeding and trying to raise their young, are these animals being less coexistent than they would be perhaps during non-breeding season? So that's another thing that we're looking at. And the last thing we're looking at, Morgan's part of her PhD, she's looking at how good are these animals at crossing roads. And there's a lot of roads of all different sizes, speed limits, traffic volume, and things of that nature that crisscross both the red fox and coyote study area. And so what we're really curious about is the more roads that an animal has to cross or encounter, does that make them better at crossing the roads because they're more experienced, or does it make them more vulnerable to getting hit by a car? And so Morgan started to look at that. And the other thing we're thinking about, or we're curious about, is these animals' spatial memory. So are these animals, if they cross the road successfully, do they constantly cross the same road at that same spot or that same general area each time because they know that that's a safer area to cross than, for example, further down the road where there might be more traffic volume or there's a higher speed limit or whatever the case might be. So those are some of the things that we're looking at to continue this research project. And then again, if you saw on the title slide, all those names along with mine, those are all collaborators who we've published papers together on this project. But this project could not be completed without just a tremendous amount of support and assistance from a variety of both undergraduate students, graduate students, veterinary students, the public. We've had a whole variety of funding sources that have helped us out. And it has just been a wonderful project to be involved with. simply because of the public enthusiasm and support and interest in what's going on. And so thank you to the funders and everybody who's helped us on this project, and we continue to look forward to future collaborations. And last thing I'll just mention here is if you're interested in this project, we do have a Facebook page. It's an open Facebook page, UW Urban Canid Project. If you just Google UW Urban Canid Project on Facebook, you'll find us. So that's the most dynamic part of our project, where we push a lot of information out through that. We've got a more static presence on the web. That's our website, so you can see the address for that there. If you do see a coyote or a fox in the Madison area, I would encourage you to Google iNaturalist and UW Urban Canid Project, and please become an iNaturalist user and report that sighting to us. It is very valuable to us. We use that data pretty consistently and reliably. And the last thing, if you are interested, it costs me about $45,000 or so each year to run this project, based on funding salaries for graduate students, undergraduate students, travel through our study area. Each satellite collar costs about $1,500 to buy. So if you're interested in supporting our project, we have a gift account through the University of Wisconsin Foundation. And if you go to the University of Wisconsin Foundation and just type in UW Urban Canid Project, you'll find our gift account there. It's a tax-free donation, and I will guarantee you that every dollar that is donated to our project we use specifically and only for our project, and it is extremely helpful, especially in this time right now when funding is so tight. It has been tight for a while, but it's especially tight now because of the coronavirus issue. So we would appreciate any funding help that we can get. Well, thank you very much for that. And I will just bring it back here so you have something better to look at than that last page. And if there are any questions, I'm happy to take them. Otherwise, I really appreciate being invited to give the Badger Talk. And anybody who wants to follow along, please follow our Facebook page. And if you're in the Madison area, get in touch. We'd love to hear from you. Thank you very much.
Hey, David, just wanted to check to see if you saw some of the questions coming in.
No, I can't. I looked at the chat room. I didn't see it. I don't see anything. Let me stop the share here and get into the chat room that way. Really
sounds
quick.
good.
Oh, I gotcha. All right. So, how do the coyotes and fox ranges change over the years? So we're not quite sure about that. And that's a really good question. So we think that the coyotes don't change very much. We think the coyotes are pretty established in the urban area here in Madison. We think that the fox are not as established, and the fox population is probably a little bit more variable than the coyote population is. And foxes tend to move around a little bit more, so they don't have and hold as much established territory like the coyotes do in the city. So that's something we're trying to figure out, because that's a curiosity to us as well. So we tend to see coyotes much more stable in terms of numbers and where they are in the landscape. Fox, the population tends to be a little bit more variable, and where they are located on the landscape is a lot more variable as well. That's a really good question. Let's see. Do we propose a significant shift in iNatural reports since this past several months due to COVID-19? We have not noticed that yet, but we are continuing to monitor that and see it. And it could be that people are noticing fox and coyotes a lot more simply because people are home more, but may just not be aware of our iNaturalist page. So that's a good question as well. Let's see. Underscore to your listeners not to use poisons for mice, chipmunks, etc. Yeah. So here's the deal with poisons or rodenticides. So a lot of times, most of the rodenticides are what we call anticoagulant rodenticides. So a rodent that is getting baited with an anticoagulant rodenticide, it has to build up enough rodenticide in the body in order for it to internally bleed to death. And as these animals, these rodents are on the landscape, if other animals come across them, and it could be a coyote, or it could be a fox, it could be a hawk, owl, whatever the case might be, if other animals start eating the rodents that have rodenticide in them, it will start moving up the food chain, and it can actually poison and kill secondary consumers of the rodenticides, such as fox and coyotes. So if you are using rodenticides, please use them extremely responsibly. Follow exactly what the manufacturer says on the back of the package. And if you see a rodent that is either sick or dead from a rodenticide, please collect that rodent and put it in some place that secondary consumers like fox and coyote cannot get access to it. We've got another proposal that we're trying to get funded where we want to look at the amount of anticoagulant rodenticide exposure to fox and coyotes. We just haven't been able to find any money about that yet, but we know it occurs. We just don't know to what extent. Let's see, how are the Owen Park coyotes doing? That's a good question. So Owen Park is one of our, it was in our study area. When we started this project in 2014, Owen Park was occupied by coyotes, and there was a territory that was defended there in Owen Park, and there was a coyote pack that lived in Owen Park. And probably over the last 2 or 3 years, even though we've been trapping in Owen Park, we haven't really seen coyotes there. So we don't know what happened to them. We know they're around, they just aren't using Owen Park as much. And there's been a lot of management activity there in terms of deer and turkey management, and we don't know if that disrupted the coyote pack and forced them to go somewhere else, or if they just moved somewhere else for some other reason. But the Owen Park coyotes, they will move through there, but they don't seem to be living in Owen Park like they were in like 2014, 15, 16, 17, things of that nature. So that's a good question. And let's see. Yeah, cats and dogs also are, they are susceptible to rodenticide exposure, just like coyotes and fox and owls and hawks are, for sure. So did I hit all the questions, Nick, or am I missing some?
We had one more just come in talking about Yep, exactly.
Yep. Yeah, so we have not studied lungworm at all. So I don't know about lungworm and the prevalence of that in either fox or coyotes, unfortunately. So sorry, I can't answer that question.
And that looks like all of them.
Let's see.
Oh, we got one more coming in too.
I think that's about the how has it changed over the time. So yeah, that's an example where the fox are changing so fox, again, their numbers and where they set up in the landscape seem to be much more variable than the coyotes. And probably once Morgan gets done with her PhD research, most likely I'm going to probably stop looking at coyotes and focus solely on red foxes, because there is something really interesting about red foxes here in Madison that is going on. And I'm not quite sure why red fox are variable in their population, like why they're not more established and consistent in the city of Madison, but they are. The population will fluctuate from year to year, and where we find them and where we go to trap them will fluctuate from year to year. And I'm not exactly sure why that is, but I'm really curious about what the heck's going on. So at some point, probably in the next 3 or 4 years, we're probably going to concentrate just on red fox and start dropping some of the coyote research, because we're not going to start discovering much more about coyotes that isn't already known. And then let's see, in the evening, we hear coyotes east of Lake Higanza. We do not study down in Lake Higanza, or that's outside of our study area. We'd like to expand our study area. We just don't have the money to do so. And what we'd like to do is move into, probably not toward Lake Higanza as much as we'd like to move into the north and eastern part of Madison. But there are definitely coyotes down there, and the coyotes make all sorts of noises. They bark, they howl, they yip, and they will bark and yip and howl if they hear other coyotes, but they'll also bark, yip, and howl if they hear sirens off of emergency vehicles, if they'll hear train whistles and things like that. So they are really interesting and just fascinating animals. I mean, fox are as well, and fox have even more, a wider range of communication than coyotes do. So what's the percentage of the diet for fox and coyotes that is small dog or kitten? It probably depends on where they are. If you go to Southern California, the percentage of diet of small dogs or cats is probably, I'm not sure what the percentage is, but it's probably a percentage of their diet is coyotes, not so much fox, but coyotes will certainly eat cats. And whether they eat the dog or not is up for discussion. They typically will kill the dog because they see the dog as a competitor in their habitat, and they were curious as to why that dog is there, or in their territory, excuse me. But whether they eat the dog is up for debate, and sometimes they will, sometimes they won't. Here in Madison, like I mentioned, we don't think that there's much aggression toward dogs by coyotes. Cats, we're not sure. And again, cats are a small enough animal that it could be that the cat, if the cat's killed or eaten, it might be not a coyote necessarily. It could be another domestic dog, a larger breed of a domestic dog. It could be a raccoon. It could be hawks, owls, whatever the case might be, like that. Fox typically don't. They might eat small cats or attack small cats. It's unlikely. Fox are much more likely to attack backyard chicken coops and things like that. What symptoms of Lyme disease are exhibited by coyotes? Similar to symptoms that you would have in humans. So it's very stiff joints, primarily just stiff joints, swollen joints, things of that nature. And we've seen coyotes with after the fact, we've figured out they've had Lyme disease after we've collared and released the animal. And based on how the animals moved, that made sense that they had Lyme disease, because they were moving kind of stiff, just like we would. And so the canids will have similar type of symptoms as humans will relative to Lyme disease. Let's see, seen a lot more red foxes and coyotes in suburbs of southeastern Wisconsin this year. And that could be that could be an explanation for if you're seeing more red fox, there may not be as many coyotes there. But again, if we're able to demonstrate that coyotes and red fox can coexist in the same space and same time, the red fox population should not be influenced by the coyote population, at least in urban areas. But again, we don't know that for a fact. However, we've not been able to document, since our project's been going on, we've not been able to document any coyote predation on red foxes in our study area. So we don't know exactly what the heck's going on with those red foxes and why they're so variable. But that is a good question that we're excited to answer here in the future. All right, so I think that is it. And thank you so much, everybody, for your interest in this project. And again, please feel free to follow along on our Facebook page. And again, if you're in the Madison area, reach out. We'd love to interact with you in person once the COVID era ends. So thank you very much.